Okay, so let's look at this question 4 from exercise 4B.2. It's about motion in a straight line. So let's do part A. Part A asks you to draw a sign diagram for the velocity and acceleration function of particle. So first we get this dx dt is equal to v, and that is 3t 18t and then plus 24, and you notice that 3 is the common factor. 6t is square and plus 8, and I can factorize this further. This is a t minus 4, t minus 2, and so the critical values of v is 4 and 2, because the two values 4 and 2 would cause this to be 0. So if you sub 4 or t before, you get 0 and then t be 2. So that's how you identify the critical value. So the next one is dv dt. This is acceleration function, and fairly straightforward. Let's just factorize this. So again, the critical value of AT is 3. Okay, is that fair? Alright, now let's get the sign diagram done. This is sign diagram of V. Okay, I line them up so you can see and make comparison. This is 2, 4 is 3. Now the reason we do this wall here, because this is when time is 0, and for real application problem like this, time negative has no real meaning. So that's the reason why we put the wall and you don't have to consider anything negative for time. Now if you do the sign diagram for this, you would realize that this is negative, positive, negative, and here you have negative, positive. And how do you know? I mean, part B of questions, and it reverses direction. Very simple. Now the velocity sign diagram of the velocity function. Now before 2 is traveling to the right, and then after time equals 2, it travels to the left. It means only one thing, that the particle actually reversed its direction like that. Okay, and when time equals 4, before that is traveling to the left, and after time equals 4, it travels back to right. So it must be a reverse there. So therefore, reverse direction at time equals 2 and 4. Okay. I'm a position, so you need to calculate this. X2 is actually 20. If you do calculate that, this is 16 meter to be precise. And we also try locate x0. So when time is 0, where's the position of the particle is actually 0. So what do we know now? So reverse direction at time t equals 2 and 4, and this is the location or the position of particle. So now we can sketch the sign. The motion diagram is when 0 here. So just put 16 and 20 meters. Just a sketch. So when time 0, the particle was here. Time 0, it travels to the right. As you can see at this from the velocity sign diagram of the velocity, this positive velocity. So when time is 2, or at location of 20 meter, it reverses direction, and then at 16 it reverses its direction again. So it's when time equals 2, here is when time equals 4. Okay, so this is a motion diagram of for the particle. So let's tackle part D, part C and D of the same problem. Okay. Oh, okay. Return here. I need a pen. And at what time? So to answer part C, you need the sign diagram. I will just do it here. 2, 4. Okay. This is for V sign diagram for V, and this is sign diagram for A. Right. This is time. Okay, time. So now, at what time is the particle speed decreasing? So all we need to do is just compare these two sign diagrams for the velocity and acceleration function. So if you check the theory, if they have different sign or opposite signs, then that's when the particle speed is decreasing. So if you notice right here, let me change a bit of color. I'll give you color so you see. Oops, sorry. Right here. Right. So here is actually negative. Here is positive. So they have different sign. And also right here, if you note it carefully, between 3 and 4, this is actually negative, positive, sorry, and here you have negative sign. So that means, so now you located, change it back to yellow. Okay, so the speed decreases when time is between 0 and 2, because the velocity, the sign diagram of velocity is positive, and the sign diagram for the acceleration here is negative. So between time between 0 and 2, and also between 3 and 4, if you check carefully, right, this is positive here, but for velocity, the sign diagram, the sign is negative between 3 and 4, so they have opposite sign. So you have answer this. How about velocity? The velocity decreasing. Now the velocity is a bit different from speed. Well, a lot of difference, but it relies on acceleration to tell you whether velocity is decreasing or increasing. So when acceleration is negative, that interval will be when velocity is decreasing. If you find that acceleration is positive at that particular interval, so we know velocity is increasing then. So clearly from the sign diagram of A, okay, velocity decreasing when t is between 0 and 3, right? And okay, lastly, find the total distance traveled by the particle in the first 5 seconds of motion. In this one, you have to look at the graph of the motion diagram. Now, if you recall, the motion diagram was like this: 16, 20. So it's a total distance traveled, not the displacement. The graph was like this. Okay, stop here. So if we find out what was the position of the particle when time is 5. So if you calculate this is equivalent to 20. It means that this is when time equals 2, time equals 4, and when time is 5, the particle is here. It was traveling in this direction, U-turn and U-turn. So all you have to just calculate, you can see from sign diagram. So the total distance is from 0 to 20, the first 2 seconds, 20 m, and from second to the 4th second, it traveled 4 meter, 20 to 16. And lastly, from the 4th second to the 5th second, it traveled another 4 meter. So therefore your total distance travel is 28, and you can just refer to the motion diagram and answer this part D as required.